Welcome to the MinStack Monthly Forum. I'm Eric North from the University of Minnesota. Before we get started with the presentation, there are just a few announcements. First, MinStack invites you to participate in the Second Harvest Heartland donation drive. For every dollar donated, the Second Harvest Heartland can provide up to 3 meals. Join fellow MinStack members in donating, and together we can help reduce food insecurity for our Minnesota communities. And thank you to Valerie McClanahan for setting up the donation opportunity, and the link is in the chat. Second, a reminder to save the date for the Minnesota Shade Tree Short Course, which will be March 15th and 16th. The conference is planned for in person at this time, and we hope that it remains so. And there's a link in the chat for that if you haven't already received information. There's also still time to register for Northern Green, which will be held on January 11th and 13th, and the link for that is also in the chat. A reminder, the presentation is being recorded and will be available via the University of Minnesota's Urban Forestry YouTube channel, and it's great if you would like to subscribe and find additional forum presentations there. If you haven't already, please consider signing up for the MinStack newsletter to receive news and information and happenings, things like the forum that are going on, and a reminder to keep yourself on mute during the presentation. And I will be monitoring the chat as we go through throughout the entire presentation. So if there are questions for the speaker, I can help or manage those as we go through. It's my pleasure to introduce Dr. Brandon Miller. Brandon is an assistant professor in the Department of Horticultural Science at the University of Minnesota. His research program aims to solve production issues that limit the development of novel nursery crops, especially those of underutilized taxa with horticultural merit. His extension program is centered on education of landscape horticulture practices and supports the introduction and application of emerging nursery crop species and selections. Brandon works with the Minnesota Landscape Arboretum and uses plant exploration to seek out unique species and provenances for plants with desirable traits for horticulture. And Brandon, if you would like to share your screen. And I've linked to Brandon's university profile if you wish to communicate with him or see the things that he's worked on. And whenever you're ready, Brandon.
Great. Can you see my screen okay, and can everybody hear me?
You sound good, and we can see your screen.
Perfect. All right. So good morning, everybody, and thank you, Dr. North, for the introduction. As Dr. North mentioned, my name is Brandon Miller. I'm a faculty member in the Department of Horticultural Science, and I was recently hired. I started in August as a state extension specialist working on cold climate perennial specialty horticultural crops. And what does that mean? Basically, I'm focusing on getting new woody plant material introduced into the nursery trade and making it or getting it available to practitioners in fields like arboriculture. So today I've got about 50 minutes worth of material, and I am going to give you a crash course on hickories with my presentation titled Hickories in Horticulture, Novel Options for Diversifying Managed Landscapes. Now, just a brief overview of what you can expect in this presentation. I'm going to start with just a very brief introduction into who I am and what my training and past, my background working with hickories. We're going to talk about the genus Carya, which is the group that comprises hickories, and we'll talk about topics like their potential for use in managed landscapes. I'm going to introduce you to 5 specific species that I recommend for use in Minnesota. And then we're going to switch gears a little bit and just give the key points to some research that I've conducted to date on some of the topics we'll talk about today. I'll give you some great take-home messages for practitioners and just end with some brief notes on topics that need to be further addressed before hickories will become commonplace in the green industry. So first, just a brief introduction into my background. My professional and academic experiences have really been centered around the green industry. Professionally, I've worked through various levels in the nursery trade, and academically, my research has really been focused on getting underutilized woody plants that do not make up large portions of our urban forest and getting them introduced into the nursery trade. Specifically, I've done a lot of work with hickories, and so we're going to talk about that today. As a extension specialist, I'm stationed at the St. Paul campus, but I also work at the Minnesota Landscape Arboretum. And so it's a really great opportunity to trial hickories and to try to work to generate new information for practitioners. So we'll kind of talk about things that I've already learned about the collections of the Minnesota Landscape Arboretum and how they can be helpful, giving some insight to practitioners in our horticulture. So as a bit of a rationale, why would we want to talk about introducing new woody plants into the managed landscape? And, I really address that question, right? I look at that question from two main views. There's two real factors that threaten our urban forests, and those are abiotic and biotic stresses, so non-living and living forces. And in recent years, especially in the upper Midwest, we've observed the challenges of exotic invaders like the emerald ash borer, insects that specialize in particular trees, or while we don't have it here in Minnesota, a more recent introduction on a national scale, the spotted lanternfly, which is a little bit more general and therefore maybe a little scarier. But this is a trend that we've observed in the past, and likely in the future, there will be new exotic pests that we need to be prepared for. And so if we can diversify our urban forests, we can hedge our bets to a degree, so that if an insect that specializes in one particular group of trees is introduced, it doesn't wipe out a large portion of our plantings. And in the same token, abiotic stress, looking at extreme weather events, which are becoming more frequent. This past year, we've had a drought. In the past, we'd be looking at flooding scenarios. And last night was actually a great example of more frequent severe weather events with the first tornado in the state of Minnesota in the month of December. So these are all issues that the trees in our urban forests need to be able to withstand going forward. And really, if we don't diversify our plantings, if we don't, incorporate different species with different tolerances, then we end up with something like this. And of course, we want to avoid, stumps of ash trees littering our landscape. And so to do that, we might look at plants that are not currently widely planted, or they're not currently comprising a large portion of our landscapes. And one such group that I propose that we should evaluate, that we should consider more broadly, are hickories. Now, when I mention hickory, a lot of folks think about shagbark hickory, which is this tree that you see here. It's a very iconic plant. It has nice exfoliating bark, golden fall color, and for some folks, they're interested in it because it produces edible nuts. But what many people don't realize is that hickories, or the genus Carya, is actually more diverse than just shagbark hickory. And there are actually 19 different species worldwide, give or take a few. It depends on who your favorite botanical authority is. But these are the 19 species that comprise the genus Carya. So these are all the hickories species you can find worldwide. And I've divided them in their three major taxonomic groups. Now, the reason I'm showing you these three groups in the columns here, pecan hickories on the left, true hickories in the middle, and Asian hickories on the right, is that while taxonomically they're different, so they're classified in this way, there are some real world, practical applications for those differences that play a role in the use of these plants in the landscape. So I'm going to mention this a handful of times throughout the presentation, which trees belong to the pecan hickories and which trees belong to the true hickories. Now, as you guessed, the Asian hickories, the column on the right, those are all plants endemic to Asia. And all of these species that are in the red rectangle here, these are all plants that you can find in North America. So the red text, Carya palmeri, that's the only plant that's restricted to Mexico, whereas all of the other plants there in black bold font within that red rectangle, those are all species that you can actually find native to the United States. So we can actually look at this distribution of these plants on a national scale. And so in this map here, states that are dark green, those are states that have hickories found within the state and on some level. And on the county level, counties that are highlighted in light green, those are counties that have at least one native species of hickory. I drew this yellow line kind of separating through the middle there. Everything west of that line, those are plants that likely have been moved around by people. So those are trees that have naturalized over time. Everything east of that, those are all likely native endemic hickories. So when we look at this, what we notice is that we have hickories that go all the way north, all the way south, plants all along the coast. And really, what does this mean? This means that there's a lot of genetic diversity that we can draw upon for use in horticulture, that we can draw upon for use in arboriculture. And there are a lot of traits that we can kind of use to our advantage. So for example, there are likely plants that can tolerate the cold temperatures of the north, the warmest climates that we have in the southern peninsula, the south of the country, down in Florida. There are plants that are adapted to coastal ecosystems, so there might be some salt tolerance. And there's just about everything in between. So this is really advantageous when we're thinking about plants from a horticultural perspective, because it just means that there's a lot of different factors that we can examine. And again, we could take advantage of to use in cultivation. Now, today we're thinking more through the lens of arboriculture. We may be thinking through the lens of plants that have good ornamental traits and also traits that make them suitable for use in managed landscapes. Although other audiences may be interested in other factors that hickories are known for: their timber value, their nut production, their ecological value, and so on and so forth. But like I said, today we're going to be talking about their use in managed landscapes. So I just want to talk about a couple of specific characteristics to kind of introduce you to hickories on the whole. And here we have bark. So while shagbark hickory is one of the more widely recognized species, and it has these really attractive exfoliating plates, exfoliating bark, this is not necessarily the case for the other species in the genus. So for example, pecan, which is the same pecan you would think of if you go to the grocery store to buy pecan nuts for maybe baking or for cooking, it's that same species, is actually a member of this genus, and it has scaly or flaky bark. And as another example, there are other species that have fissured bark, like we see on the right with the Laney's hybrid hickory. In the same token, there are other traits that are desirable for use in cultivation. The autumnal display, the fall color of these plants, is highly sought after amongst horticulturists, and some hickories have some of the best fall color of temperate species that are available. Usually they're in the range of yellow to more of the orange range, and so we see a lot of really good golden yellow fall color, or in the case of like pignut hickory, which we see in the middle here, a really desirable amber fall color. Now, I mentioned that when we were looking at that the US map, we were looking at where you can find just hickories on a generic level, that likely there are plants that are adapted to different sites. And if we go into the wild and we look at these plants, we see that that is in fact the case. For example, we have plants like the shagbark hickory, which tend to be found on more mesic sites or upland sites. So potentially, you know, they're growing on rocky outcroppings. There may be some drought tolerance there. Or we also have specific plants that are adapted to niche riparian habitats or wetland areas like rivers and creeks and so forth. And so we really have a lot of stress tolerance traits, really in the way of root zone moisture or soil moisture content, whether that be drought or flooding tolerance, or possibly plants that they're plastic and they can kind of tolerate both ends of that spectrum. And this is ideal for use in urban sites because as most of you know, as all of you know, urban sites are unique locations. They have unique conditions. Typically drought is very common, or ebbing and flowing between temperature extremes or moisture extremes. These are all conditions that our trees need to be able to tolerate. And so while hickories are not very common in the nursery trade, so you don't really see them planted very frequently, when you do find them, we end up finding them doing rather well. If you look in the literature, especially older texts, the word resilient seems to be associated with hickories. And the truth is that we don't really have evidence to support, how resilient hickories are. But because they do seem to be very adaptable to a variety of conditions, and because when we do find them, they seem to be doing very well, that we suspect resiliency. Now, I'd be remiss not to mention the fruit. As I mentioned, pecan is a member of this genus. These are pecan nuts here. So the fruit of a hickory is a nut. They are all edible. However, some are more desirable than others. Now, pecan as a major nut crop in the United States and around the globe, there's been a lot of research into its production, but really there's not been a lot of research into its relatives. When we're thinking about fruit from a managed landscape perspective, one thing that we might think about is size. So there's a lot of variability between the different species and the size of the fruit. And you can see here with the fruits on the left-hand side, the three groups of fruit on the left-hand side, those are all bitternut hickory fruits. So they're all the same species, but there's a bit of variation within that species and how big the fruit can be. So the group on the very far left, a little bit smaller than the third group in from the left. Now, if you compare that species to the shellbark hickory or the kingnut hickory, which is that group of fruit on the very far right, obviously there's a huge difference in size there. And so when we're thinking about placing these plants in the landscape, the size of the fruit is something we might think about, just to make sure that we're not putting them somewhere where they become an issue, or maybe they become messy. And really what I'm trying to say is there are different sizes of fruits amongst the different species. And so likely we can match the species that we have to the specific site that we're trying to plant on. So perhaps these fruit are too large for use as a street tree, but this plant, and I'll tell you a bit more why you might like this particular species, could be well suited to parks or larger green spaces. A final thought on fruit that I just want to mention is that there are some folks who would argue that we should disqualify hickories from use in urban landscapes because they produce fruit. I argue that that's not necessarily the case. With anything, we need to match the specific species to the site that we're trying to plant. And the way I would phrase it is, ask yourself, if you would plant an oak on this particular site, if you would do that, if the acorns are suitable for that location, then odds are there is a species of hickory that would perform well without becoming a hindrance as well. So if we don't have issues planting oaks, we really shouldn't have issues planting hickories. And one final thought on that, again, match the plant to the site. So the fruit, the nuts, are of course consumed by humans, but they are also integral components to ecosystems throughout the United States. Hickories, because they've adapted to so many of those different ecosystems, are integral components of those habitats. And so there's a lot of ecological value of hickories in the wild. And so if we bring these plants into cultivation, we hope that we can bring some of those ecosystem services into our manipulated environment, into our artificial environment. So you may be wondering, Brandon, if these plants are so great, then why do we not already see them all throughout the landscape? And really this stems from a handful of issues in the nursery production sector. And I've attributed those issues to three main categories: transplanting, propagation, and production. Now, some of these issues we have data to back up. Some of these issues seem to be more myth or rumor. And so why don't we go ahead and kind of review those different factors and learn more about that. So limitations for hickories in the landscape. If you have spoke with individuals in the nursery trade, especially amongst horticulturists, there's this generalization that because hickories have a strong taproot, that they simply cannot be transplanted, or that if you transplant them, they end up failing most of the time. And the reality is that there really hasn't been historical data to support that, for reasons that we'll get into later in the presentation. Ultimately, there are methods for successful transplant of hickories. So it is a bit of a myth to attribute all hickories as incredibly difficult to transplant. And so, like I said, we'll get into that a little bit more later, but this is one thing that odds are most people who have talked about hickories have heard this, that because they have taproots, they don't transplant well. And, it is true that they do have a taproot. That's not something I'm trying to argue. And you can see that from day one after germination. Now, these are seedlings shortly after germination of 3 different species of hickory. And you can see that those seedlings are putting a lot of energy into taproot development. And that taproot does persist, as we saw in the last slide, past their juvenile phase. So for some plants, they have that taproot when they're young, and then as they mature, the taproot no longer has so much of a dominance in the root architecture. These plants do seem to have that strong protuberant taproot throughout their lifespan. And the issue with this is during that juvenile phase, that because most hickories are grown from seed, for the first handful of years, when nursery growers are trying to cultivate these plants, the hickory seedlings are putting energy into taproot development, not in the shoot. So this then attributes to the perceived slow shoot growth of hickories. And so it's not uncommon for 3, 4, 5 years into production after growing seedlings to still have plants that are less than a foot tall. And here we can see in these images, these are shagbark hickories. These are the end of their 2nd year of development. And you may be saying, I don't see them. That's the point. They're really small for a 2-year-old plant. And really, this is one of those factors that some nursery growers tend to shy away from growing hickories because of this, because they're slow to grow and because it takes so long to have a profitable, saleable plant. In the same token, because hickories are mainly cultivated by seed, we end up getting a lot of variability in plantings. So these 2 pictures, these are plants from a nursery who was trialing shagbark hickory in Western New York. So if we look at the image on the left, we have the 2 arrows pointing to 2 very different plants. And these plants are all 6 years old in this production setting. So they've been in this field for 6 years. And we can see that the plant on the left has a really nice, strong central leader. It's about 5 or 6 feet tall. It's encroaching on 1-inch caliper diameter. It's a nice saleable tree. Whereas you see the plant on the right, its counterpart in the row has taken on this shrubby form. It's maybe a foot or 2 feet tall. It's not a saleable plant. So if we look at the image on the right, we're zooming over, we're adding 1 more plant in the row, and we can see that next plant over has done the same thing. It's taken on this shrubby habit. And so what's the problem here? Well, while we have 1 plant that's at a saleable size, we have 2 here on this right-hand side that are nowhere near saleable, and they don't seem to be on track to be saleable in the near future. So this is an investment for nursery growers. In this case, it's a 6-year investment, and you've got 1 plant saleable, and in this example, 2 that are not. And it's just simply not a sustainable crop production schedule. So then you may ask yourself, well, if we are growing them from seed and there's so much variation, why don't we just produce them asexually or clonally like we do for many other woody plants? And there are techniques that are available for producing hickories clonally, but those techniques are really more suited towards nut production and orchards. In these pictures here, we have 3 different examples of top grafted hickories. Now, for a variety of reasons, this is not suited to use in the managed landscape. It's not suited for ornamental purposes. One of the reasons is simply because that graft union, which in each of these cases, there's some level of graft incompatibility where those 2 portions, the top, the scion, and the bottom, the rootstock, they're just not meshing well together. On the one hand, because bark is one of the features we're interested in, it simply doesn't look good. So from an ornamental perspective, there's that perspective, there's that view. And then from a arboricultural perspective, this plant in the middle is destined for failure when we get a strong storm. So this kind of incompatibility just isn't suited to the long haul with plants in the managed landscape. So my research as both a graduate student and now as a faculty member at the University of Minnesota has really been aimed at taking these small plants that we see on the left and trying to find workarounds to get those plants to a saleable size, to make them productive, to make them valuable to nursery growers, and therefore make them available for practitioners. Now I'm going to switch gears ever so slightly. Before getting into some of the take-home messages for the research that I've conducted, what I first want to do is introduce you to 5 different species that I would recommend for growers in Minnesota, or I would recommend to folks who are looking to plant hickories in Minnesota. And these recommendations are largely based on the limitations that we have within our state, mainly cold climate. We need to make sure that these plants can survive our winters. And so on the right, I have the USDA cold hardiness zone map for the state of Minnesota. And for folks that aren't familiar with this, this is a system of zones that are based off of 30-year averages of low temperature extremes in the winter. And so in the north, we have zone 3A, which is our coldest zone. And then if we go further south, we have a gradient all the way down to the southern border of Minnesota, where we have a sliver of zone 5A. So the higher the number, the warmer, more mild the winters. And so for example, 3A, the expected maximum temperatures that you, minimum temperatures you would expect for 3A are -35 to -40 Fahrenheit. And again, these are based off of 30-year averages, so this map does get updated over time. So the first plant that I want to introduce you to is Carya cordiformis. It's called the bitternut hickory. And if you don't take anything else away from this presentation, take away that this plant is probably the most valuable species I'm recommending for use throughout the state of Minnesota. And the reason for this is if we look at the distribution of this plant in the wild, I'm showing the distribution on a national scale, but you can see that in the state of Minnesota, it grows throughout all of the zones that we have in our state. And so it does have potential, or it does have cold hardiness traits throughout zone 3. And that's a bit unique for the hickories. This is probably our most cold hardy hickory. Now, this one belongs to that pecan hickory group. If you think back to that earlier slide where I said taxonomically, they're broken up into sections, this is a pecan hickory. Now, one of the reasons why that fact is valuable is that taxonomically, they're broken up because of their relatedness. And so certain plants within the group share certain characteristics. So if we look for those certain characteristics, it helps us to identify which species we're working with. Now, pecan hickory species have valvate scales. If you look at that terminal bud, what you see is that it almost looks like small miniaturized leaves that are clasping, kind of holding that bud together. Those are naked buds or valvate, naked scales or naked buds. And that's a trait of the pecan hickories. Now we could further identify this plant to the species level because the bud on this plant is sulfur yellow in color. So if you see the naked bud, this miniaturized leaf kind of clasping the terminal bud together, and you see it's sulfur yellow, you have a bitternut hickory. It's pretty unique amongst all of the plants in this genus. It's the other way you can identify this plant, or additional features you can look for are looking at the number of leaflets on the leaf. So hickories have a compound leaf, much like an ash tree. They do not have a simple leaf with one blade attached to the stem, like an elm, for example. So instead, you have multiple leaflets that compose one unit, one leaf. And the leaves of hickories are polymorphic. What does that mean? It means that they kind of change. There are no two leaves that are exactly alike, is one way of kind of thinking about it. So for example, with these leaves all from the same tree, there's 2 that have 5 leaflets, and there's 1 leaf that has 7 leaflets. Typically with this plant, there's 7 to 11 leaflets. Occasionally you find 5. So if you look these plants up in reference books, that's what that means. They do look a lot like Fraxinus. They do look a lot like ash trees. And when we look at the bark of this plant, it does not have exfoliating bark. It actually has ridged bark. And you can almost see a near diamond-shaped pattern. And so sometimes this plant does get confused with ash trees, especially in the wild, because they often grow in close association with one another. So where you might find green ash, for example, you might also find bitternut hickory. The fruit on this plant is a bit smaller. It has a leathery casing, and so you can see a bit of variability in the size of the fruits here, sampled from different populations of plants in the wild. And really, one of the ideal features of this plant is the golden fall color. It has outstanding fall color. And while in the wild, you often find it on riparian habitats, you do also see it on more upland, well-drained sites. And this plant in cultivation seems to be very adaptable. So it's a great plant to have in a tool in the tool belt, if you will, for urban application. The next plant is Carya glabra, the pignut hickory. And we can see one of these plants poking through a canopy of oak trees here. Now, if we look at the distribution of pignut hickory, we notice it's not a native to the state of Minnesota. It is found throughout the eastern United States. And based on collection history at the Minnesota Landscape Arboretum, this plant has performed very well in zone 4. So zone 4 is more of the cold hardiness limit as far as we can tell right now. It is a true hickory, so it belongs to that other subset of hickory plants. And what does that mean if it's a true hickory? I don't have it in the picture here, but if you look at the buds on these plants, they have overlapping scales, much like if you looked at the terminal bud of an oak. If you look very closely, they have little scales that are overlapping, kind of like the scales of a fish, for example. So true hickories have overlapping scales. This plant you would typically find in the wild on more dry upland sites. It has between 5 and 7 leaflets, and it's without hairs. So in tree ID, if you look in the textbooks, the presence of hairs in certain parts of the plant can help you differentiate between species. Glabra means glabrous, which means without hairs. So that's a little bit of ID fun for that. The fruits of these plants, when they're mature, are very aromatic and spicy. It's quite a pleasant smell. And the bark, again, not exfoliating, but it does have quite a unique pattern. When they're younger, they tend to be scaly. And as they mature, they tend to have a more ridged, furrowed bark. The claim to fame with this species is its fall color. It has outstanding amber fall color, probably the best fall color of any of our temperate hickory species. So if you find this plant, this is one of those ideal ornamental features. Carya illinoinensis, also known as the pecan, or if you purchase plants from the northern part of its native range, the northern pecan. This plant is typically thought of as being grown in the south, and that's true for nut production. But when you look at them in the wild, it inhabits the entire Mississippi River watershed, and it grows up as far north as northern Illinois or north central Iowa along the Mississippi River. So it is hardy to zone 4. This is a species that we have active accessions of in the Minnesota Landscape Arboretum, perfectly hardy. This plant is a member of the pecan hickory group, so it will have those valvate or naked buds. And it's associated with riverlands with second bottoms. What does that mean? If you go to the Mississippi River, you won't find this plant growing directly along the bank. You would find it on the second tier up in elevation. So near the river, but not adjacent to. And the leaves on this plant, they're a bit bigger. They typically have between 11 and 17 leaflets, but they can have up to as many as 21. The fruit on this plant typically doesn't develop when we bring these further north. And really that's attributed to the shorter growing season, especially if you get plants from a little bit further south that are adapted to a longer growing season. So what does that mean? It means that if you bring those plants up north, they have the potential for being cold hardy, but they likely won't produce mature fruit. And that can be ideal for managed landscape settings where you will have less fruit and the fruit that does develop won't mature, so it doesn't get quite as large. The bark is quite appealing. When they mature, they develop this scaly bark, and it can also develop a nice yellow fall color. Carya liceniosa, the kingnut or the shellbark hickory, is the second to last plant that I want to introduce you to. If we look at the native range of this plant, it has a patchy distribution across the central United States and into the eastern United States. And what does that mean? It means that there's a lot of populations that are isolated. So there's a lot of potential for variation between plants of different populations. When you find it in the wild, it tends to occur on riparian sites or wetland habitats. This is a plant you would find holding the bank together on a river or on an inlet of a lake, for example. This is another plant that we have accessions of in the Minnesota Landscape Arboretum. It is hardy in zone 4. We have a number of very nice mature specimens. So this definitely is a plant that can be used in central Minnesota. If we look at the leaves, they can be very large. Now, an old name for this plant was kingnut hickory. More recent literature refers to this as the shellbark hickory. And really the reason it was once called the kingnut hickory is because all the parts of this plant are much larger than all of its relatives. So it's hard to tell with this image, but leaves, the whole leaf, that's an entire leaf, that whole leaf can actually attain lengths of 2 to 3 feet long. So this is a very large structured plant. And the 3 feet long leaves may be the shade leaves. However, they're still very large, and it gives a very unique kind of look in the landscape. As I said, all the parts of this plant are bigger. The stems are much more stout, which we can see here. You can kind of see in this image that terminal bud has scales that are overlapping. This is August, or yeah, this is August. This is mid to late growing season. So those scales are still developing, but that's what we're talking about with the true hickories. If you want to identify this plant, an easy way to do it is to look for the retained rachis. So we're looking up into the canopy of a plant, and the rachis is that stalk of a leaf. It's the stalk that holds the leaflets and attaches it to the stem. In the fall, when the leaves drop, the leaflets fall, but this species seems to retain that stalk. It retains that rachis, and you can kind of see it on this young plant here in a nursery. The fruit on this plant also has the potential to get quite large. Because the populations are isolated, I've seen some plants that have very small fruit, no bigger than a shagbark hickory. I've seen some that have fruits that are somewhere between the size of a baseball and a softball. And so while that may be desirable for nut production, obviously we want to be careful when we're placing these plants in managed landscapes. We want to make sure we don't get a softball sized fruit planted as a street tree. Again, I'll talk a little bit more about why this plant is still merits attention, it still merits use, but just something to be aware of when you're siting plants. This is one of those species that does have nice exfoliating bark. It looks very similar to a shagbark hickory, but all the features of it are much larger. And in the wild, you'll find it almost exclusively on, in wetland locations. It does have good fall color. This picture doesn't do it any justice, so don't judge the plant on my poor photography skills, but trust me, this does have really nice yellow fall color. Now, I mentioned in the wild, you'll find this plant on riparian sites or wetland sites. You can occasionally find it on dry sites. It just tends to be rare in the wild, but when we bring them into cultivation, the species seems to do very well just about anywhere you put it, so it's highly adaptable. The last plant I want to talk about is the shagbark hickory, Carya ovata. This plant is native to southeast Minnesota. We have our range map here. So it's native throughout the eastern United States, but it is a native to the state of Minnesota. And if we look, we can see it's that southeast corner of the state. It belongs to the true hickory group, and leaves typically have 5 leaflets, although you can sometimes see 7. The claim to fame on this plant is its absolutely fantastic exfoliating bark. This provides interest year round. And of course it provides, unique winter interest. It's a plant that's absolutely hardy into USDA zone 4. So this would could be planted through central Minnesota. I'd question if possibly it could be pushed a little bit further up into 3B. I don't have any evidence for that though. So maybe that'll be a talk in the future once we figure that out. Another ideal feature of this plant is it does have really nice golden fall color. So all in all, it's an excellent tree, native to the state, durable, has excellent ornamental qualities, and also seems to be rather adaptable. One of the issues, however, is that this seems to be one of the slowest growing plants from a seedling. And because the species is so iconic, because it's arguably the most well recognized, I wonder if this fact has kind of created some of the generalizations, some of the rumors associated with the entire group of hickories. And we'll talk about how that's not necessarily true momentarily. The nuts are edible and they're smaller, maybe about an inch across in diameter with the husk. So in many cases, they're no bigger than a bur oak acorn. And of course, there are other hickories that have potential for use in the state of Minnesota. I've listed a handful here. Carya tomentosa, or the mocker nut hickory, is one that I suspect would have cold hardiness, but what would really be interesting is to evaluate its salt tolerance, because that's a plant that often grows up onto the coast in the eastern United States. There are a variety of hybrids, which I haven't mentioned so far in this presentation, but some of these species do hybridize. And so there's opportunity for incorporating those plants in the landscape. And then there are other species that just really haven't been tested in Minnesota. Sand hickory and black hickory are two that would be quite interesting to evaluate in the future. Now we're going to switch gears one more time. I'm going to go over a handful of takeaway messages from some research that I've conducted to date. And this slide and the two following it are the most complex. So don't be intimidated by all the jargon and all the things that are going on here. What we did though was we evaluated predicted drought tolerance of a handful of species and hybrids. And twigs representing those hybrids and species are on the left. The Latin name for those plants is on the right. So those are along the y-axis. From top to bottom, if you can see my cursor, Carya glabra, that's the pignut hickory, Dunbar's hybrid, pecan, shagbark hickory, bitternut hickory, Nussbaum's hekin, and the shellbark or kingnut hickory. And what we did is we used vapor pressure osmometry. I'm not going to get into the details behind the physiology of this, but we used a predictive tool to determine a relative ranking of drought tolerance in these plants. And what we found is that Carya glabra, the pignut hickory, was our least predicted drought tolerant. If you want to figure out what do I mean, which ones are least drought tolerant, which ones are most, on the x-axis here, if we're looking at these black bars, the plants that are more negative, the plants that lean towards the left here on this x-axis, those are more drought tolerant, whereas the ones that are less negative are predicted to be less drought tolerant. So we saw pignut hickory up at the top, Dunbar's hickory, pecan, shagbark hickory right in the middle. And what was interesting was we had our riparian plants, our wetland plants that aggregated towards the bottom, which according to our data indicates they have potential for being the most drought tolerant. So why would that be? Why would plants that we would find growing inundated in water be more drought tolerant? One hypothesis that we have is because those locations, if you look at those plants in the wild, while some parts of the year they are inundated with water, rivers, swamps, the moisture kind of ebbs and flows. And so while at one point of the year they're inundated, other parts of the year they tend to be quite dry. And riparian habitats typically have a clay pan layer. So those taproots likely aren't penetrating down into deeper soil profiles. So they're not accessing water deeper down in those soil profiles during the dry parts of the year. So it's quite possible that contrary to what we might kind of assume, that our riparian species may actually be more plastic in their ability to tolerate wet conditions and dry conditions. And these are excellent traits for use in managed landscapes. We did this again, just looking at that one species, just looking at kingnut hickory. And what we did is we compared two separate populations. And if you remember, I said the populations of this plant, the distribution is really patchy. So there's isolated groups, which typically lends to variability. And all in all, what did we find? We found that if we sampled two separate populations, their predicted drought tolerance did vary. So there's quite a bit of variation, not just in physical features, but in possibly stress tolerance. We looked at pignut hickory, which has this outstanding fall color, and we assessed 10 separate individual trees within one group. And these were plants in Ithaca, New York. And again, we're looking at these black bars here. If we looked at that, what we found is there's a significant amount of variation between individuals, even within a group. And really what this means is that if we could clonally propagate, if we could find these trees like tree number 8, which has excellent predicted drought tolerance traits, if we could clonally propagate that plant may be particularly well suited to the conditions of the urban environment. Now, I mentioned that clonal propagation is difficult with the current techniques that are available in horticulture. And part of my PhD research was trying to find a workaround for that. We ended up looking at other models and we noticed that mound layering was a technique used for apple rootstock production. We tried it with a handful of hickories and found it to be very successful for shagbark hickory. So in doing this, we rooted these, they're called layers, but we rooted these individual pieces, got them on their own root. And what was fascinating is that the roots that we were able to encourage with this process are fibrous. They do not have coarse roots. They don't produce that taproot like you would see with seedling grown material. So not only might we have a workaround for clonal propagation, but we might also have a workaround for issues associated with taproots if that proves to be problematic going forward. Another issue I mentioned is that those seedlings tend to be really slow to develop their shoots when they're young. And so horticulturally, there are a handful of chemical compounds that are sometimes used to manipulate growth of various plants. So we looked at a group of compounds called gibberellins. So these are plant growth regulators. And what we did was we tried to apply gibberellins, which have kind of control over shoot extension. And we applied them to different hickory plants. And we have bitternut hickory here on the left and pecan here on the right. We had untreated controls that didn't get any treatment. And then we have these plants where we put that gibberellic acid on the stem, or we put that gibberellic acid on the bud. And this was done in the spring. And what we found is if we applied that to the bud, we ended up getting nearly a doubling in shoot extension for bitternut hickory and for pecan. Now, both of these plants are both within that pecan hickory subgrouping that I've mentioned throughout the presentation. All the plants in the true hickory grouping, like shellbark hickory, shagbark hickory, pignut, so forth, those plants did not respond to this methodology. So there seems to be some other kind of control here, but what needs to be further explored is could this be implemented in the nursery to try to focus energy into shoot development to maybe get a shorter crop turnover in the nursery. We also wanted to know, could you grow these plants successfully in containers? Seems like a pretty basic question, but most people and most assumptions are based on plants grown in the field that would be transplanted, bare root, or balled and burlapped. And so we did a 4-year evaluation looking at bitternut hickory, pecan, kingnut hickory, and shagbark hickory. And that's the order from left to right in both of these images of plants. So we got bare root whips and we grew them in these containers. And what we found is that these plants grew really well in containers. We had a replication of plants in the field. The plants in the field were a lot slower to grow. And we chalk this up really to, containers. We were able to control the inputs. So we were able to give them the fertilizer that they needed to control irrigation, control growing temperatures. And so container production seems to be a viable option for hickories. And to further that point, not only does it seem to be a viable option, but for some of these species, they seem to grow much faster in containers than they did in the field. Now, what you'll notice is that on the right-hand side, we have shagbark hickories, and they're hard to see compared to our kingnuts, our pecans, and our bitternut hickory. And, again, shagbark hickory is that more iconic species that most people are familiar with, and it seems to be a bit unique in how it behaves in production. So these images were taken the first week of October in central New York a couple of years back. And at that time, the shagbarks have already shut down. They're waiting for the next growing season. These other 3 species, they haven't even colored up yet. They're much bigger. They're still growing strong. And so really what I'm trying to say here is that we figured out you can't paint all hickories. You can't put them all in one grouping. The different species seem to respond and grow in unique ways. So they really need to be assessed on a case-by-case basis. Of course, when you find an answer, you sometimes also find more problems. So while our plants grew really well in containers, especially for the first 2 years, in year 3, our pecan hickory types, our northern pecan and our bitternut hickory, started to display these really strange symptoms that almost looked like herbicide damage. We determined it wasn't herbicide damage based on where the plants were, and we thought maybe this is a nutritional issue. We looked back to the literature. Of course, there's been a lot of research already done on pecan because it's a major nut crop. And what we found is that pecan is susceptible to something called Mauser disorder. This is essentially just a function of nickel deficiency, elemental nickel. And it's a rather unusual deficiency that seems to be restricted to nursery production. When grown in containers, the plants are grown in artificial substrates. So it's not actual field soil, which typically has plenty of available nickel. The container substrates don't have as much available nickel. And so we see this deficiency appear rather quickly. And another reason for this is that most fertilizers don't provide nickel because most plants don't need them in high amounts, but hickories seem to need more. So we did an assessment. We found that bitternut hickory and pecan are particularly susceptible to this in nursery production. So growers need to supplement nickel. And then a year or two later, we started seeing symptoms on our true hickories, on our king nut hickory, our mocker nuts, and our pig nuts. And so while we didn't evaluate these formally, the symptoms do seem very similar. So we suspect that this is all mouse ear disorder. And we suspect that simply growers need to supplement nickel to have healthy plants in containers, and they seem to grow rather quickly. So just a handful of recommendations for practitioners based off of some of the information I've shared, and based off of some of the myths that are, abundant in horticulture. Can balled and burlapped plants actually be transplanted? And we did a transplanting assessment of large shagbark hickory. I'm assessing large shagbark hickory as 1-inch caliper. While that's not large for a lot of woody plants, for hickories, that's pretty big, because they take so long to grow. And so we found that balled and burlapped shagbark hickory transplanted in the spring transplanted very well. We didn't assess fall, so I can't attest to how these plants may do in the fall transplanting season, but they did rather well. Now, bare root larger shagbark hickory, that's another story. That was kind of more hit or miss, and so we would caution folks against planting bare root. Larger bare root shagbark hickory. But if you can find balled and burlap plants, just make sure that you're watering them adequately. They seem to do very well. And if you can't find larger plants, which is most likely the case because so few growers are actively producing these trees, smaller plants in containers or smaller bare root stock seem to do very well. So we had bare root whips. They came from Forestry nurseries. They were sold as 12 to 24-inch tall bare root whips. Those transplanted very well. And our plants that we grew into 10-gallon containers, we didn't have a single plant die of any of those 5 species that I've recommended in this presentation. So if you can find a grower that's producing container grown plants, if you have the ability to grow or to plant smaller bare root stock, those seem to transplant very well. And looking forward, what still needs to be done? This is an evolving topic, and we haven't got all the answers yet. We really need to refine the nursery production techniques for hickories. We need to modify our propagation, production, and transplanting methods. And selection and breeding. I'm not a breeder, but for folks who may be working with plants, who may be looking at plants every day, if you notice plants that have superior ornamental characteristics, characteristics that make them well suited to expanded application purposes or suited to production, if they behave themselves in the nursery row, and also plants that seem to be particularly tolerant to stresses. These are all plants that we could select and we could clonally propagate to introduce into the trade. Of course, we need more people to trial hickories in Minnesota. This is something that I hope to do at the Minnesota Landscape Arboretum. But finally, as a call to action, something that practitioners could do today, this year, next year, we need to demonstrate demand. We need to demonstrate to growers that there are folks who might actually be interested in planting these trees. So the next time you go to order trees, ask your supplier, do you have hickories? Do you know anybody who produces hickory? And if they do, that's great. If they don't, which is likely the case, they will inquire with their suppliers. They'll call around. And the more times that hickory comes up in folks who are looking to purchase plants, the more that the nursery growers will consider adopting these into their crop schedules. And with any luck and a little bit of effort, this will hopefully be a commonplace sight in the landscape. We'll have some new additions to the landscape, like these shagbark hickories, the plant on the left from Ithaca, New York, or the plant on the right that was recently planted on the St. Paul campus of the University of Minnesota. And with that, I'd like to thank you all for your time today. I've put my contact information up here. Feel free to reach out with comments, questions. And again, I also put my faculty profile web link there. So I'd like to thank you all for your attention and would love to take time for any questions.
Thank you, Brandon. That was a great presentation. There's a few questions that have been generated, and I'll go through those. And Karen Zumach, president of MinStack, also had a brief announcement at the end when all of the questions have been addressed. So the first question came in from Steve Nicholson. He wanted to know about Phenopsis on butternut or maybe bitternut. He has both in the question here. Is is ugly, but is it lethal, and should it limit the use of those plants?
That's a good question. Phomopsis, I believe I've seen it on bitternut hickory. It rarely occurs, but it can affect those plants. Whether or not it's lethal, that, I actually don't have a good answer to that. I've seen plants that are heavily infected with Phomopsis. And, I think it was more, they looked bad. I don't know that it killed the plants. I would caution though, if you're aware of plants that are spreading Phomopsis, maybe to cull those plants so that it doesn't continue to do that. So, I don't have an honestly good question to that. If you email me, I could look that up and look into it and get back to you, but I'm fairly confident they can live a long time with Phomopsis infection.
Great, thank you. Excuse me. Question about the shagbark hickory distribution map. It looked like St. Louis County was highlighted to have shagbark hickory. Is that correct? And if so, does anybody know where there might be some located?
So the maps, that's a good question. So the maps that I shared were from BONAP. You can find those online, BONAP. You can look up just about any plant in North America. So those are based off of records, whether they are current or historical. So at some point, somebody has recorded a hickory in that county if it's showing up on BONAP. Occasionally, you do get some records that probably there were plants that were planted, they may not have native origin. So occasionally stuff like that falls through the cracks. I don't know about that exact county reference, but I would suspect that if it was on there, in some capacity, the plant has been recorded in the state.
Good. Do you know where people could actually purchase 1-inch diameter shagbark hickory from the nursery industry? Are you familiar?
It's an excellent question. There are a few growers who are producing them. In New York State, there's Schichtel's Nursery. I know they're producing them, but that's a little ways away. More regionally, Johnson's Nursery in Menominee Falls, Wisconsin, has been producing shagbark, and I know that they produce 1 and I believe 2-inch caliper shagbark hickory. So Johnson's Nursery in Menominee Falls, Wisconsin, would be a go-to for larger material at this time.
Excellent. Do growth rates increase at some stage for compared to the earlier years of production? So do growth rates of the hickories actually increase?
Excellent question. Yes, the growth rate does change over time. So when I was talking about how when they're juvenile, the trees put a lot of energy into the taproot. What I should have emphasized is that they kind of neglect shoot growth during their juvenile phase, but once they kind of phase change, once they get into their more mature habit, they suddenly start putting on these larger, shoot extension amounts. And so, yes, they do eventually grow in a more typical habit. They don't have short amounts of shoot extension throughout their entire lifespan.
All right, good. Last question I'm going to combine two here. Has there been a market for shellbark, and which hickory is best for human consumption?
That's a tough question, and probably there's some opinion and bias in there with my answer here. So shellbark is a good plant. It typically has thicker shells, so sometimes it's harder to crack. There are cultivars that are hard to find, but they do have thinner shells. The hybrids with shellbark hickory may be a good option. Shagbark hickory has smaller nuts, but the nuts are much thinner shelled. They're much easier to crack, and they have a high ratio of the nut meat, the seed portion that you're trying to eat, compared to the shell, as opposed to shellbark hickory. So it kind of depends. I've eaten both. I think they're great. If anybody hasn't tried it, they taste just like pecan. So give it a whirl. But that's another arena that horticulturists need to improve. Selection of nuts for northern production. But there are folks that grow them, and there are cultivars.
Very good, Karen Zumak. If you want to join us, if you're still with the call, and you can make your announcement.
Hello, everyone. Thanks, Dr. Miller. That was a great presentation. Anytime we can add some diversity to our palette here in Minnesota, the better. So I appreciate that opportunity to learn some more about that today. Of course, I thank all of you for joining us today. What an amazing turnout. I hope you all at least had a Christmas cookie or something to kind of simulate how we would have been at the chalet today. Maybe a fire in the fireplace. I do definitely miss getting together with everyone, especially for this forum. It always is a great opportunity to connect with everyone. So I just encourage people to reach out and have conversations and chat with, maybe you see a person on the call today that you haven't talked to in a while, maybe reach out and just check in, see how people are doing and see what they're up to. The other thing I want to say is thank you to Eric and Ryan for all your great work this year, getting these forums together. We've had some great opportunities to learn some new and cool things. And all of us have been able to access it because of your great prowess with this technology. So thanks for that. Of course, the DNR, thank you for supporting MNSAC and the forums that we're able to deliver with university every month generally. So just trying to get a little gratitude out there today. The other thing is, if you're feeling like you really want to know what's going on with the MNSAC board, there are lots of open positions right now, and we'd love to get some new people on the team. So check out our website. We can put that into the, thanks, Eric. And then lastly, just wanted to give a quick, if you haven't heard about the EAB grant program that is open right now, I just wanted to add that extra encouragement that if you're a community looking for some additional funding to help support your emerald ash borer management programming, that grant is open through January, up until January 24th. There's a great webinar that was put together that's also on that U4 page, and I hope everyone will apply that's able. So that's the end of my announcements. I hope everyone has a happy and safe holiday season, and we'll look forward to seeing you hopefully soon in person. So thanks, everybody.
Thank you for that, Karen, and thanks everyone for attending, and enjoy your holiday season, and hope to see you in the new year.